Hi guys, let's get on with some revision for this test that we've got coming up. Let's pick a nice pen. Hopefully that one works. Okay, right, here we go. The keywords in algebra are simplify, expand, factorize, solve, substitute. Okay, and then there's a little bit of sequences in this, which is a little bit separate from algebra. It's included because we talk about nth term and things like that, which we'll mention as we go through it. So let's start with simplify. Simplify by collecting like terms, families, collect the families together. We don't create new families, so we're not times in to make x squared or a squared. We're just literally going, right, what have we got? So if we take some of the harder ones here, I don't even think these go hard enough really. I might set you a challenge of something. There's nothing really that goes negative here. Can we take a look at the bottom one where we've got 4 A's, add 3 A's, add another A. So we've got 8 A's in total. Okay, and then we've got 9 B's, which I'll mark above, and we're adding 2 B's, so we've got 11 B's. I don't think these go tricky enough, guys. My apologies. Hopefully you are watching this. We need to deal with going into the negatives as well. So if we take something like 3A minus 2B plus 3A plus 7B, okay? Then in terms of A's, we've got 3A plus 3A, which is 6A, and we've got minus 2B plus 7B. So minus 2 plus 7 is plus 5B. Or even more tricky than that, something like 6x plus 3y minus x minus 12y or 11y, that'll do. So this time we've got a circle of 6x minus, take 1 away to give 5x, and then 3y's, positive 3y's, and we're taking away 11 from the 3 to go down to minus 8. Always remember, chaps, that if 4 plus 7 is 11, but also if you're taking away something completely different, you can go down into the negatives. If you're taking away more than you got, you go into the negatives. I know that's a stupid point for a clever group like you, but just, yeah, be careful of it. Now we're into single brackets. Expand single brackets, okay? 3 times 2p is 6p. 3 times 4q is 12q. X times x is x squared. X times 4 is 4x, but we're not timesing 4, we're actually timesing minus 4, so it will become minus 4x. And 2x times x is 2x squared. 2x times 3 is 6x. That's fine. That's totally fine, right? So multiply what's inside the bracket. Multiply the two things inside the bracket by whatever's outside the bracket. I think you're all happy with that. Now, in terms of factorizing, you see that there's two terms. So even if it doesn't say into single brackets, the giveaway that it's into single brackets is 1, 2 terms, 1, 2 terms. Okay, we're looking for common number or letter factors. So factorize means in this case, okay, what goes into these things could be a number that goes into both terms or could be a letter. So in the first one, the common number factor is 5. Both these numbers are in the 5 times table. If I take 5 out of 5x, I'm just left with x. If I take 5 out of 15 or divide it by 5, I'm left with 3. Here the common factor is 7. Okay, whereas here there's not a number. There's not a number common factor. There's a letter that's common. This is x times x, and this is 6 times x. Well, if I take an x out of both those things, right, then I'm left with just x in the first term and just the 6 in the second term. Okay, now more likely for you, or more common at higher tier, both a number and a letter that's common. So I've got to be careful here because 42 and 12, 2 is a common factor. 4 isn't. 6 could be. 12. Okay, just got to check. Right? Just be careful that you're getting the highest common factor. And it turns out here to be 6, but we can also take an x out. Ask yourself, 6 times what would give 42? 7. X times what would give x squared? I need the x there. Plus 6 times what would give 12? 2. And x times what gives x? Well, I don't need another x in there because the x that was in the 12x I've taken outside. So that's single bracket. Okay, before we come into double brackets, we've actually taken a bit of a change in lane here. We've and our fourth word is solving. Solve this, okay? I'm jumping from the first few, okay, which you can probably do in your heads to some of these down here. Okay, with this one, I would expand my bracket first. I would always expand the bracket when you're solving. You don't want to be working with brackets. So 2x minus 10 times both those things by 2 equals 9. Leave my x's on the left side, as we always say. Move my numbers to the right-hand side, where the negative 10, sorry, that's your magic bridge, as we would call it, would become positive 10. So 2x equals 19. And then divide by what's before the x to find what x is, okay? With this one, you'd move the plus 2 and take it away from the 17 and then divide by 5. So you'd end up with 15 as your answer, but you'd have to divide them by that 5, so x equals 3. Then it's slightly harder because I've got x's on the wrong side. I've got x's on the right-hand side that I just don't want there. I want you to come over and be with these 5 x's over here, but this number still needs to go and be on the right-hand side. So the 5x isn't moving. The plus 2x, the positive amount of x's over here, will now be negative 2x's. The 32 isn't moving, but the plus 5 that was on the left is now over on the right-hand side, and minus 5. We're left with 3x equals 27. So x equals 27 divided by 3, or x equals 9. Now, sometimes they put solving equations into a picture, okay, and make you create the equation yourself, right? So we're told the perimeter of the above shape is 840 centimeters, okay? Perimeter means all the way around the outside. So what I want you to think for perimeter is put a little person here and take them for a walk all the way around until they get back to where they started. How far have they walked? Well, they've walked 3x. Add another x, 4x. Add another x, 5x. Add another x, 6x. Now, we don't know how long the bottom is. However, if we look at the top, okay, we've got a over to b is 3x, and then c over to d is another x. So in total, that length is 4x. Added on to the 6x already, we're up to 10x. And the same for this length from f back to a. Okay, from f to d is x, and from C up to B is also x, so this side is 2x, okay? So in total, all the way around, if you added all the x's together, you get 12x. Now, we're told, actually, yes, the perimeter is 12x, but we're then told, but in reality, when we've actually worked this out, the answer is 840. So 12 lots of what will give me 840? That looks tricky, but it's not. Because 12 goes into 84, right? 12 goes into 84 7 times, and we can just put that 0 back on the end. So the answer is 70, okay? However, we then use that to go, how long is the line FE? Well, the line FE, according to my drawing, is 4x long. But I now know something I didn't. I now know that x is 70. So 4x is 470s, or 280. Okay, let me come back to that screen. We've still got a bit of time left. Sometimes my videos cut out after 15 minutes, so I'm just wary to check back and forth. So if there's a bit of a break in this, it's just my video cutting out, and I'll restart from wherever I am. Okay, earlier on we did single bracket expanding. Now we're going to do some double bracket expanding, and the method I'm going to use is the smiley face. But basically, right, everything in the first bracket times everything in the second bracket. So you might, some of us got used to this, taking the first term and multiplying it by the second bracket, then taking the second term plus 7 and multiplying it by the second bracket. So you effectively turn it into 2 single brackets, right? Probably not what I would do, maybe, right? I think I'm more inclined, let's use a different color for a minute so you can see the difference. I'm more inclined to do like my smiley face method, which is x times x is x squared. The nose, 7 times x is 7x. The mouth, x times plus 2 is It's plus 2x. And finally, the other eyebrow, which is plus 7 times plus 2, and a plus times a plus is a plus, and 7 2s are 14. It does ask us to simplify our answer. So we've got three different families here. We've got the x squared family, the x family, and the number family. Well, the only thing in the x squared family is that. In the x family, we've got 7x's, add another 2x's, which is 9x's. And then we've got the 14 on the end. And this one, x times x, again, x squared, plus 9 times x, minus 3 times x. And the bit that most people get wrong is this, actually, the numbers, because it's not 9 take away 3, it's 9 or plus 9 times minus 3. That's what that eyebrow is doing. And 9 3s are 27. Positive 9 times negative 3 means that that's negative. Again, x squared, these are in the same family. 9x take away 3x is 6x minus 27. I think this is where I shall take my break and come back to you almost immediately. Okay, sorry if there was a bit of a break there. I'll pick up exactly where we were. Now, earlier on we said factorizing means put into brackets. Now, I think I prefer red. You can just see it a bit better. Let's go back to a red pen. When there were two terms, right? For example, x squared plus 12x, that is single bracket factorizing. X plus 12, you can take the x out. And you can see the difficulty with these though, right? When there's three terms, there's no number that can come out of all three terms, and there's no letter that can come out. All right, we can take an x out of the first two terms, but not out of the third term. Can take numbers, you see the point. These are called quadratic. They're called quadratic, okay, or quadratic formula, because you've got an x squared family, something from the x family, and a number, okay? And when you've got that, right, you're always going to go into double brackets. So, and the brackets will be x, yeah, x. I'll get you a mark, okay? And with both these then, you're looking for a pair of numbers to go in here that will times to make the end number, and add or take away to make the middle number. Whereas I'm not so bothered about the sign on the end number, though I'm really, really important that I get that plus 8 in there. Okay, same here. By the way, this is wrong. This is wrong, right? That plus there, that should be minus. I will explain that in a second. Hopefully you've got this right anyway. However, we're going to times to make the end number, which doesn't matter here, but I'll show you why it should have been a minus, and add or take away to make the middle number. That does matter, okay? With the first one, I really hope you've got 3 times 5 and 3 plus 5. So plus 3 plus 5 are your two answers. With your second one, 12 times 2, that I can't make 2 with those, actually, no. 3 times 8, I can't make 2 with those. 4 times 6, I can, right? It's positive 2, it's positive 2, it's not negative, so it's going to be 6 take away 4, right? Okay, but actually, if you were expanding this, remember that 6 times minus 4 is minus 24. So when you're doing the kind of, if you were expanding these, that's why that should be minus, not plus. But you may have got that right anyway, just by ignoring the sign on it. Okay, right, exactly the same, but with hence solve. Okay, too easy, too harder. I hope these match yours. Can't remember if I slightly tweaked your version, but anyway, hopefully you can listen in and try the ones that you've got. No, too easy. Let's go here. X, but equals 0, slightly different. Now, times to make that, add or take away to make that, and I'm really interested that it's minus 2. Don't really care about the 35. 7 times 5, I'm straight there, okay. But 7 take away 5 is 2, and that is not what I want. 5 take away 7 is minus 2, and that is what I want. So it's 5 take away 7. Don't worry too much if you've got those the other way around. If you've got the minus 7 in the first bracket and the plus 5 in the second bracket, as long as you've got the correct sign for the right each number, okay? Slight difference here though, we've got to solve this now. So this is where we say, okay, either what's in the first bracket needs to be 0, or what's in the second bracket needs to be 0. Now, we're trying to work out what x needs to be to make these be 0. Okay, so what add 5 equals 0? Well, the quickest way to do it is a bit magic bridge and go, well, the opposite of plus 5 is minus 5, and the opposite of minus 7 is plus 7. So the actual answers to a solve question are the opposite to what goes in the brackets for the factorized bit. Plus 5 in the bracket, minus 5 for the solve. Minus 7 in the bracket, plus 7 for the answer, if that makes sense. And now the ridiculous ones. Absolutely stupid, right? Same method, 3 differences. Difference number 1. If it's 3x squared, put 3x in your bracket. If it's 2x squared, put 2x in your bracket. Right? Okay. We're still going to use team. Second difference. Okay. The second difference is, if there is a number before the x squared, the end number here has to times by that to create a new end number. So in team, we're timesing to make the end, but the end, I've got to times it by 3, so the new end number is minus 15. However, the middle number is still minus 14. The pair I'm looking at there is 1 times 15, and to make minus 14, I'm looking at 1 take away 15. So plus 1 and take away 15. I'm coming to this side. Again, times to make the end, add or take away to middle, but the end needs to be multiplied by 2, so that it's not minus 12 anymore, it's minus 24. But the middle doesn't change, and remember, it's the middle one, that's the sign, where the sign is really important. Same here. I have to make minus 14, not 14. Okay, 3 times 8, I believe, is the one that's going to give me minus 5. And 3 take away 8 will give me the minus 5. So positive 3 and take away 8. Okay, so first difference, you start the brackets with 3x, 3x, or 2x, 2x. Second difference, the end number has to be timed by the start number to get a new end number. Third difference, you have to, any bracket that will divide by a number, if the numbers in a certain bracket will divide by 2, or divide by 3, or divide by 4, or whatever it is, you got to do it. So 3x plus 1 won't divide by anything other than 1, but 3x minus 15, both those numbers are in the 3 times table and can be divided by 3. So what I've decided is I won't change the first bracket, but I will divide the second bracket by 3, both things in it, and get that. Here, 2 and 3 won't divide by anything, but 2 and 8 are both in the 2 times table. So my final answer, 2x plus 3, and half of 2x is x, half of minus 8 is minus 4. Okay, still have to do the either or bit. Either that bracket equals 0, or that bracket equals 0. Okay, this is an easy one, because we just take the minus 5 over and get x equals 5. This one, not so easy. If we take the plus over, we get minus 1, but it's 3x equals minus 1. And I don't want to know what 3x is, I want to know what x is. So that minus 1 has to divide by 3, and by all means, you can leave your answers like that. And for this one, 2x plus 3 equals 0, or x minus 4 equals 0. Opposite of minus 4 is plus 4. Opposite of plus 3 is minus 3, but in this case, I got to divide that minus 3 by 2, write it as a fraction. So in some of these, in these harder ones like C and D, often one of your answers is going to end up being a fraction and one will be a whole number. That's quite common, I would say. What we got left? Substitution. Okay. All right, there's some numbers. We're just going to put them in here and work out the answers, find the values. Okay. A plus C. Okay, if you add a minus, it becomes a takeaway. So this becomes 5 minus 6, which is minus 1. D squared. Okay, that's easy enough. 2 lots of A, 2 lots of 5, plus 3 lots of D, 3 lots of 10. Okay, not so bad. 2 lots of D, which is 20, minus C, which is minus 6. Here, I've done 2 of those, 2 Ds, which is 20, but I'm taking away something that is negative. I'm taking away a negative number now, whereas earlier, or just now, we added a minus and it became a minus. If we take away a minus, those 2 minuses will become a plus. So that's 26. And ABD literally means A times B times D. So A times B times D. Now, the hard bit is the half, isn't it? Right? But when you're multiplying, you can do multiplication in any order and get the same answer. So if you don't fancy doing 5 times a half times 10, you could do 5 times 10, which is 50, and then times a half. So half of 50, which is 25. But whichever way around you times those, you're going to get 25. And lastly, hurrah, we're on to sequences. Write the first 3 terms. Okay, first 3 terms. First term, 3 times 1, add 8. 11. Second term, swap n for this for 2, which is 14. Third term, 17. Here, 2 times 1, take away 5, work that out, minus 3. 2 times 2, take away 5, minus 1. And 2 times 3, take away 5, which is 1. Okay, so to find the first 3 terms, you swap n for 1 and work out an answer. Then you swap n for 2 and work out an answer. Then you swap n for 3. It's very much like substitution, but you're substituting in the numbers 1, then 2, then 3 to get 3 different answers. Okay, and the last thing, okay, if they're going up by common amounts, 3, 3, 3, then it's 3n, come back a number in the sequence plus 1. This is going up 7, 7, 7. Then it's 7n, but if we come back 7 from there, we go back down to minus 2, which goes there. Okay. However, if they're going up by different amounts, 3, 5, 7, 9, which is common, same here, 3, 5, 7, 9, then you have to compare these with n squared. Now, the n squared sequence is 1 squared, 2 squared, 3 squared, 4 squared, and so on. So as numbers, that would be 1, 4, 9, and 16. If we compare that with our first sequence, 3, 6, 11, and 18, you can see in our sequence, every single number is 2 more than the n squared sequence. So this sequence is the n squared sequence, but I'd have to add 2 onto every number. Or if we start again with that n squared, 1, 4, 9, 16, and write our second one, minus 1, 2, 7, and 14. This time, every number in our sequence is 2 lower than the n squared sequence. So this is the n squared sequence, but we'd have to take away 2 from every number to get that. Okay. Other things I just want you to be aware of, I think you know this, things like this, right? Know the difference between x times x, which is x squared, and x plus x, which is 2x. Okay, I know it sounds obvious, but yeah, don't fall into that trap. If you're multiplying, you kind of create a new family, right? X squared. But if you're just adding, you're just collecting things in the family together. Oh, also know that in algebra, we wouldn't write half x. We'd write x divided by 2. They are the same thing. I think that pops up as a sort of little 1 marker. So just little things like that. But if you can follow everything I've done here, you're in a good place, and I shall see you for the test.